Here we go. All right.
I'm Justin Balderas.
And I'm Colin Gould.
And we are doing our CP3 on STEAM. What is STEAM? STEAM is how you integrate the following subjects. S stands for science, T stands for technology, E stands for engineering, A stands for art, and M stands for math. And the purpose of STEAM is students will begin to see knowledge and interdependent and connected rather than individual isolated subjects. So the subjects will blend instead of being their own, like math just being math and science being science, they can kind of blend together. This will help students with higher level critical thinking and collaborative skills. As students' ability to use these skills and information is more interrelated way, the more structured the learning becomes.
Their metacognitive transfer of knowledge from different situations to the next becomes easier, which supports the student's growth. Basically, it becomes easier for them to move between different areas, different disciplines, outside of the school settings. If something's going on, they can move these ideas from one area to another way easier than it would be if they didn't have these different kinds of lessons. And what I've read from most of the articles that I looked at, it said teachers should always make it a priority to converse with their other colleagues about what their subjects actually have in common, so they're able to create lessons that really apply to both subjects. And you should work with your other teachers. And unfortunately, it said that a lot of times that some teachers kind of not necessarily talk down on the other subjects that the students learn, but just how they're taught certain lessons. So it says to always work with your teachers, your fellow teachers, on lessons that you can do cross-curricular.
And then how to create a successful cross-curricular lesson. For STEAM, a successful STEAM lesson will have two objectives from at least two of the subjects that you plan on using in your lesson. And for students to really gain something from the lesson, it needs to have a real-world application, and it needs to be something that they can use in real life.
Something that they'll see in a real-life situation is obviously going to hit a lot harder, because it's something that they're going to use. It's something that they can relate to, and that's important. It should be something that's hands-on and gets them truly engaged in the learning experience. And I know I've learned from different situations that they have to be engaged if learning is going to occur. They need to be interested in the subject or the lesson that they're learning. It needs to involve higher level thinking skills. This is for every subject. You want them to be able to develop those thinking skills that they can use later on in life or for other situations in the classroom setting as well. And then the parts of the two disciplines should be things that naturally occur with one another. You cannot force two things to work together.
And then our first problem is you have a map with an entire United States on it. You want to know how many miles to drive would be from Wichita, Kansas to all the way to Los Angeles, California. The only problem is that your map only gives you a scale instead of distances. For every 1 inch of the map, it is 100 miles of actual distance. You measure out the distance on your map, and it comes to 13 inches. How many miles are you going to travel to get to Los Angeles? So for this, they would...
Basically, what they would do is the main part of the geography lesson, I guess you would say, is they'd have to find Wichita, Kansas on the map. They have to find where it is in relation to Los Angeles, California. And basically they take their ruler and they measure out the distance between the two. And like I said in the problem, when they did this, they got 13 inches. And basically you just take 100 times 13, and you get your 1,300, and that's how many miles it is to get from Wichita to Los Angeles, and that answer is D.
And for our second problem, our upper level one, we have on average, in a given computer science class, men will outnumber women by 8 to 2. In the STEM classes, about 25% of all students are Asian. In a computer science class at Wichita State, there are 73 men. How many Asian women will there be in the class, given the averages?
Okay, so our answers are 10, 15, 4, and 9. So basically, what they're going to do, they're going to start with what they know, that there's, basically, there's going to be 20% women in a certain class because we gave them 8 men to 2 women, so that equals 10, and 2 out of 10 is 20%. So they take the 73 men, and we divide that by the 8, and we get 9.125. And basically what that is, that equals 10% of the class that are going to be 9.125. So then we multiply that number by 2 to get our 20% of women, and that number comes out to be 18.25. So that's how many women on average there are in any given computer science class. Once we know this, then we need to multiply by 0.25 or 25%, and that's how many, on average, how many computer science classes have an Asian population, or how many Asian there are in a certain class. So when we do this, we take 18.25 multiplied by 0.25, we get 4.56. We round down since you can't have half a person, so we get 4 Asian females in a computer science class, on any given computer science class at WSU.
And that's the end.
That's the end.